If you draw a single card from a 52 card deck, what is the probability that you draw a 7 given that you did not draw a face card? Now remember, from those 52 cards, we have our 12 face cards. The face cards are the actual cards that have faces. There are 4 jacks, 4 queens, and 4 kings. Those are the 12 face cards. If we know that the card we drew was not a face card, then we can take those 12 cards, those 12 face cards, out of the sample space. So there are 40 cards in what I usually call our reduced sample space. It's reduced by what we're given. Now from those 40 cards, there are 4 sevens. And why do I care about that? Because they want to know the probability that we draw a 7, basically given that there are only 40 cards in the deck because you got rid of all the face cards. So the probability of drawing a 7, given the fact that the card you drew was not a face card, is simply the 4 sevens out of the 40 cards remaining, which of course reduces to 1/10. If you roll a single die, what is the probability that you roll a 4 given that it is even? Now keep in mind that the sample space for rolling a single die is 1, 2, 3, 4, 5, or 6. But if we're given that the roll was even, that knocks out all of the odd possibilities, leaving us only the evens. So the reduced sample space consists of just 2, 4, and 6. So now I can answer the question very easily. What's the probability that I get a 4 given that the roll was even? Well, there's only one 4 out of the 3 elements in the reduced sample space. So the probability of drawing a 4 given that the roll was even is 1/3. A jar contains 25 blue marbles, 20 red marbles, and 5 green marbles. Let the event E be the first marble is blue, and let the event F be the second marble is red. If 2 marbles are randomly drawn without replacement, what is the probability of F given E? Now keep in mind, in our sample space, we began with 25 blue, 20 red, and 5 green. If you add those all up, you'll discover that that's a total of 50. The question we're being asked is, what is the probability of F given E? Now, in my opinion, it's much easier if you just put that into words. F is the event that the second marble is red, so I'll just change it. It just seems easier to me. Given E, and E is that the first one is blue. So it's the probability the second's red given that the first is blue. And that's the probability we're looking for. Well, if we're given that the first one is blue, the initial sample space has 50 marbles. But if the first one is blue, then I no longer have 25 blue marbles. After I've drawn the first marble and I know that it's blue, that leaves only 25 blue marbles. But the reds stay the same and the greens stay the same. And now I only have 49 total marbles. So this is my reduced sample space. It's what I'm left with after the condition has been imposed. So I'm really home free now. The probability of F given E, which again, as I said earlier, is the probability that the second one is red given that the first one is blue. Is simply the number. I'm looking now for the probability that the second is red, so it's simply the number of reds over the number in the reduced sample space. Well, there are 20 reds and there are 49 elements in the reduced sample space, and that does not reduce. So the probability that the second one is red given the first one is blue is 20/49.